CAD 911, please state the nature of your emergency.
Well, I went in search of someone needing help. Right here. T.G. McKenna. He wants to build a kitchen that's an addition that sticks out from his house. Well, it's not his house, it's for someone, a friend. So that it has this curved, swooped cathedral look. And the problem he had was chief architect doesn't really draw the framing correctly. And he was wondering, let me see here, I shouldn't have double-clicked that. If you look closely, this is not the way it should be. So I thought, I can help him. But by the time I was done, I guess he has a solution, because way down here, he says, hey, got it all fixed. There you go. But I'm going to walk you through the process of what I did to do this. And it'll be from the ground up in the order that you build. So this would be the bottom plates of the new structure. I have no idea if it's on a crawl space. I was more focused on the roof. Studs. Everything needs studs. All walls need studs. And then here's something that I learned from Larry. The actual window opening is here. And often when he was framing, and he started back in the mid-60s, in order to prevent the sheetrock to crack around windows, which sometimes happens, they would just extend the header to the next stud and then fill in. And now there's a whole lot less tension here, so that when your sheetrock comes around here, you minimize the risk of having cracks. I'm sure there's people that'll be like, that's so wasteful, whatever. You don't want to do it, don't do it. Nobody's telling you to do it. And that's what you get here. You get commentary from a former framer. There's the top plate, and there's even, in the framing world, there's even different terminology. I was always taught bottom plate, top plate. Those two plates get layouts so that you can build walls. And then the plate that goes on top of that, we call that the double plate. And its sole purpose in life is just to tie together connections. Like if this plate was longer than a single plate, this top plate, and it was two pieces, then you would use a double plate to splice over the connection. This wall in the back is the existing wall, and that's why you see it's drawn like that, but you could always overlap it. It would be stronger if you did. So this little swoop roof is going to take plywood, and I figured out the size, and I'll show you. You're going to make a bunch of these patterns. So I could dimension this, but in SketchUp, 3D dimensioning is kind of corny, so I don't want to waste your time. I need a beam. This is inside. From what I looked at on his pictures, this is all open, so when you're coming in from the house, it's open. So you'll have to put a beam in that existing rake wall they have, and you might even clip these plates out if you want it to be flush with the ceiling. But then again, this room's going to have a cathedral, so it doesn't really matter. This could be just fine like this. Then you're going to need beams that are going to hold the two different types of rafter. You'll have a conventional straight rafter on one side and a swoop rafter on the other. And so to get these angles and stuff, you're going to need taller than what you expect. So I figure 14-inch LVLs with 8 and 12, or correction, 10 and 12, I think is what it looks like. I could be wrong, though. There wasn't a lot of technical detail. So then pressure blocks. You're going to need pressure blocks so that when you shoot, the swoops are made out of plywood, 2 pieces each. So when you toenail them in, you're also going to benefit having face nailing into the pressure blocks. And you'll have the same pressure block system on the inside. They call them pressure block, but really all it is just giving you, this is nailed securely to the beam, and then you can toenail your rafter and face nail your rafter, so you just get a better contact. It has nothing to do with pressure. So here's your plywood swoop rafters, and like I said, they're a 3/4 inch plus a 3/4 inch, glued, screwed, however you want to fabricate these so that they become solid rafters. And you need to use CDX. Don't use OSB. And try to run it in the strength axis this direction, because the fibers are longer in this direction. So this is more better. Lateral blocking, yep, you need to run blocking in there. It looks to me like you're not going to get convection because you're a cathedral and you got beams in the way. So this ceiling will probably be fully spray foamed, and it'll just be like a SIPS roof. So from there, I think I have this out of sequence, but you would raise the ridge by putting the skeleton together, and that's how you would hold it in place. And if you look closely, this is how I always like to do my gable studs. I like to notch them, take 1.5 inches out of there, and a bevel in the front. And I know there's guys out there that, oh, that's too slow. Get good. Get good at what you do, and you can go fast. But if your focus is you're swimming with the bottom feeders on bidding prices, and in your mind you think it's faster just to go some other way, then you got to do what you got to do, man. There's the upper rafters. I always tried to find builders who wanted extreme quality, and they would pay it. I mean, man, we used to get, like, if you were lucky, $3.25 a square foot. And then, man, there's people up here, $14 a square foot. It's pretty amazing. But, okay, so there's the swoop. So I don't know. I just looked at it, and there's a couple things I have a problem with. This swoop comes down to almost being like a 0 and 12 at the end. And so I don't know where this is, if it's in Massachusetts and they get lots of snow. The snow comes down, and it's going to pile up right here on the edges, on the tails, because it's not even a slope to let the water run off. So I'm sure they don't quite go the way I've got them drawn. I'm pretty sure you're going to have at least some kind of slope. But if you're using asphalt shingles, or any kind of shingle, technically, anything less than a 3 and 12, it fails in doing its job. So I'm not sure what kind of material is going on here. A whole bunch of ice and water shield, and then whatever. See, it's cool. In the computer, you can do anything, even things wrong. So there's your standard conventional sub fascia, and it's tied in to the swoop fascia with some blocking on the inside just to keep it so everything stays tight. I don't know how in that part of the country they do things. And then the last thing I did was, I don't know. I've seen this done a lot. Some people like the peak to go right to the top, but then it's kind of a pain for the electrician to do anything. So if you had any kind of suspended lighting or fans, what I've been told is, hey, bevel a 2x6, center it, and shoot it in there so that you create a mechanical flat spot that they can work from. And who knows, somebody might want a fake beam even. You could build a box down and over and back up, make it look like a big piece of timber if you felt like it. But and this is all in SketchUp. This is all the only tools that I used that were extensions. I haven't really dove into the Medic BIM as much as I should, but some of his general tools, like his extend and his trim tool, are amazing. So I use that. But it just seems like in my life, the projects I end up doing are so non-conventional that I don't get to use all the cool tools that make life easy. I end up having to just manually do everything. But this is my representation of how that works. And only reason I jumped on it was the gentleman sounded like he needed help, and I like real world applications. So to me, this motivated me to get it done. I think this will be cool, especially like here's X-ray. If I can, come on, X-ray. There you go. If I could take different directional 3D shots of this and add them as a non-scaled detail, it would just add more understanding to whoever's building it. All right, here comes the cool video part with the music and everything.